So for this one, it says if the distance between two objects is halved, the gravitational force between them, what? Okay. So again, let's talk about that. So I've got this object here. Well, I don't want that. So I got this object here, and I've got this object here. They could be planets, they could be whatever. So there is a gravitational force. This is being pulled towards this one, and this is being pulled towards this one. And to calculate that force between two objects, there's a couple of ways that you can calculate the force between two objects. One, the main one when you have two objects is the gravitational force between two objects is the gravitational constant g times the mass of the first object times the mass of the second objects all over the distance between them, which we say r. Because gravitational force is actually a gravitational field that has a radius. And so that distance r goes from here, actually, that distance goes from the center of mass for this object all the way to the center of mass for this object. I didn't do a very good job. I got a little sloppy there towards the end. Okay, that is our distance, r. So now if I cut that in half, what happens? Well, then what does cutting in half mean? Well, really what I'm saying is that I'm going to take r and I'm going to divide that by 2, right? So then that means I would have a different gravitational force, which would be g times m1 times m2 all over r over 2 divided by, or r divided by 2 squared. Now, if you do the math on that, that becomes g r m1 times m2 all over r squared divided by 4. Okay? All right, well, we're almost there, guys. All right, so now remember that when you divide by a fraction, you multiply by the reciprocal. So that is basically what happens there is that you're going to say g times m1 times m2 times 4 all over r squared. Or if you want to clean it up, you toss the 4 to the front times g times m1 times m2 all over r squared. Okay? So really when you have these objects, you increase by a factor of 4. Okay? So mathematically what you're doing, and it's because it's so if I triple it, or let me take that back. If I decrease it by a third, then the gravitational force will be 9 times higher. So you're taking the reciprocal, like if you divide by 3, you would take 3 and square it, which is 9. Does that make sense? Whatever you're decreasing it by, you would take the reciprocal and square it, and that's what you're increasing it by. Same thing happens when if you increase the distance. If you double the distance, then you would decrease it by 4, because you would say 2 times r, and then you would square that 2, and that would be 4. If you were to triple the distance, you would decrease the gravitational force by 1/9. Okay, so I don't know if that helps anybody.